Hello students, I want to go kind of the next section. So what we did yesterday is we ended right here. We came up with the equation of the line. For this one, it was the time that it takes for delivery depending upon the number of items purchased, the location, and the experience. As we go through it, so then we came up with our equation from, let me scroll down, we had to, here we go, so we had to use the add-ons, and we had to go XL minor, and then from there, first one is our y-intercept, then we looked at the slope for the items, the slope for the locations, and the slope for the experience. And that's where we got our equation from. So we use these right here, 1, 2, 3, 4, to come up with it. Again, the first one, intercept, is your y-intercept, slope, slope, and slope. So now what I want us to do is we're going to come up next is we are going to use that equation to come up with a prediction of the time that it takes. So once again, we're going to use our equation here. So the equation we came up with, we wanted a predicted time. So now we're going to come here and put in our predicted time. So our predicted time is equal to 1.93 plus 0.28 times our first X value, that's our items, plus 0.57 times our locations, plus our experience of 0.21 times the experience, and hit enter. And it will give us a predicted time, 5.86 compared to 9.3. Then we'll go ahead, drag it down, and again, just compare these times. They should be changing. If I see sometimes, in some years I've seen like 5.86 and then 6.07, 6.07, 6. So make sure we're checking to see if these correspond at all. So 4.1, 5.1, 5.6, 5.3, 5.3, 4.9, 6.28, 8.8, 8.61. So we can see that there is a correlation. We do see some correspondence between them as we go through. So yesterday, you just use the XL minor, come up with the summary output for the two problems, and then come up with your equation. Today, now you're going to put in the predicted time. So we're going to kind of go through this step by step throughout the week. So first thing we're looking at is our equation. Now we use this equation to come up with our predicted time. Make sure your predicted time and the actual time, there should be some correspondence, and we'll actually kind of look at that moving forward. So that's what you're going to do today, is make sure you're going to have, again, you'll see the same spreadsheet, so you can use what you did yesterday and add to it and moving forward. So come up with your equation yesterday, today, now predicted time.